The agency has brought us closer to the stars, but the most valuable asset to this day remains human capital. But there are thousands of individuals who have worked over decades to make those missions a reality.
I think it's the biggest challenge for many people. I think you might find it's common is the data itself. One, having access to the data, to the right data. Now, once you have access to that data, being able to actually use the data in the way we need to for analysis. Is it in the right format? Is it in the right grouping? Do you have the right information? We, not NASA, but I think the industry in general, everybody, we store data for storage sake. Let's just put it into a database so that we have it for later use. Knowledge, skills, abilities, tactics, technology. So now I can tie training to those particular elements. So if I know I need to upskill somebody in a particular skill, these are the courses you need to take in order to get that right information. Because it all starts with the data. Everything that we do, the data has to be there, it has to be accessible, it has to be clean, it has to be ready. If we could spend less time worrying about cleaning it and more analyzing it, I think we can move the needle a lot further and faster.
This is where we bridge the gap between innovation and scientific discovery. This is where technology meets science, a podcast by Upskilling. Each episode brings you insights from industry leaders who are pushing the boundaries of what's possible in life sciences. Enjoy, and if you like the series, click that subscribe button. This series is brought to you by Upskilling, a technology company that empowers pharmaceutical and life science companies to leverage open source technology for faster, data-driven decision-making in regulated environments. Welcome back to our podcast where technology meets science. Today we have a guest from NASA. The company is renowned for its innovative discoveries that push the boundaries of space exploration. And with the integration of AI, advanced technologies, and substantial investments, the agency has brought us closer to the stars. But the most valuable asset to this day remains human capital. And without dedicated individuals experimenting with diverse ideas, our progress in that area would not have been possible. And we often recognize iconic figures like Neil Armstrong, Buzz Aldrin from Apollo 11, but there are thousands of individuals who have worked over decades to make those missions a reality. And today we're going to speak with a person who is ensuring that the right individuals are matched with the appropriate roles. He employs data science to align knowledge, skills, and competencies with specific missions and programs. Meet David Meza, Head of Analytics at the Human Capital Office at NASA. Welcome. Good to have you here. How are you today?
I'm doing well, Nat. Thank you for inviting me. It's a pleasure to be here, and I look forward to the conversation.
I hope I didn't make any mistakes in the introduction. I know you leverage data science to choose the skills and competencies for essential for space exploration, but I want to start with asking you what was your journey to acquire skills that landed you a job that so many people dream of?
Well, interesting. Yeah, so my journey has been very different across, I guess my career. I started off primarily in IT, looking at how we can just, create. And of course, I grew up in a generation when IT was just getting started. So a lot of things are just learning how to set up computers, working within the system. That started my career at NASA, actually, as somebody who could support the workforce implementing the latest technologies. At that time, we're talking about very slow computers and trying to get them set up. That just fueled my interest to learn more about technology, more about computer science, do more and more programming, which led me to understanding IT itself from a project management perspective, trying to figure out how do we implement IT in an organization, which really came down to finding that there was a lot of processes that needed to be improved in order for IT to really help. So that led me down a Six Sigma journey, which led me to analytics within Six Sigma to try to understand the variance of different processes, which really made me understand that we needed to really work with our data to turn it into some type of actionable knowledge, which then set me to knowledge management as a career where I developed a framework that I call knowledge architecture at Johnson Space Center, which is a combination of data science, informatics, and knowledge management, where knowledge management is a strategy for how we do how we use our data, how we store it, present it, and various things. Data science with the algorithms for us to be able to turn that data into some type of actionable knowledge, and informatics at the pipeline that moves the data from point A to point B. All of that eventually led me to more of a data science career to try to set up the infrastructure and architecture in the organizations at NASA, which then landed me a job within the human capital area to try to figure out how we modernize that architecture in order to support our people and allow us to be able to attract and retain the best and brightest to help support our mission at NASA.
Okay, thank you. We're talking a lot about the progress and then like your interest that you started taking when you started working at NASA, first at IT, trying to fix some different things. So what, if we think about data science, what were the biggest challenges when you first started dealing with human capital?
Oh, good. I think it's the biggest challenge for many people. I think you might find it's common is the data itself. Having access to the data, to the right data. Now, once you have access to that data, being able to actually use the data in the way you need to for analysis. Is it in the right format? Is it in the right grouping? Do you have the right information? Part of the biggest problem is that over the years, we not NASA, but I think the industry in general, everybody, we've stored data for storage sake. Let's just put it into a database so that we have it for later use. We basically mimicked our file cabinets of long ago, where we just threw everything into our file cabinets. We kind of did that in our database. It's there, but you still have to search through it to try to figure out analysis. So one of my biggest challenges was turning that storage into what I call AI ML ready curated data sets. So in this sense, we're taking all of that storage information and put it in data sets that are ready for some type of analysis. And in the human capital world, that could be time to hire, it could be attrition, it could be around retention, various metrics we may look at, looking at our workforce, looking at, again, our skills across our workforce. Do we have the right ones? All of that stuff has to be put into data sets that we could actually use in analysis. That was a very difficult challenge to try to get that ready.
And what sources of data do you have?
So, of course, we have our internal sources of data, which is our personnel data warehouse, which is where we store all our information about our workforce, our civil servants that work. Along with that, we've got external sources that we utilize for things such as USA Jobs, USA Staffing, about where we get information about the hiring, people that are being hired, the announcements that are out there for individuals to apply for. And then from that, you get the information of the individuals themselves when appropriate and when allowed. Their resumes is a good source of data for them. Their publications, their writings, things that we can find. Social media has really helped in the sense that we can now, again, with the user's approval, download some of the information from LinkedIn or some other social media that allows us to understand their skill sets and things that they want to share with us. Part of the hardest part is making sure that we have the right information about the individuals so that we can make the proper assessment to verify they've got the skills necessary to do the jobs we're trying to do.
So you're also using data, like public available data from social media to assess the potential recruits.
We're available, and maybe not necessarily assess, but to understand what we feel they have in their resume, in their work, the experiences that they may have. If they've written an article, let's say on robotics, and some of the things they're talking about within robotics, we might be able to ascertain from that document particular skill sets that they may have. Since they're writing about it and have experience on it, that may be crucial or necessary or something we may be looking for within NASA.
So to what extent that whole process is automated, and then to what extent you actually use the human capital, people, recruiters to then assess those people in further stages?
Yeah, well, to be honest, I mean, most of the work is still done by people. It's a people job, it's a people business, from the recruitment to the connecting with the individual, setting up the interviews and working through that. What we've been trying to do and working on in the last several years is just to get a good understanding of what the possibilities are, not only from an occupational standpoint, what are the skills necessary for an occupation, but what are the skills that a person may have to meet or to match to that occupation. So what I've been doing over the last 5 years is really taking a look at how we can organize that information in a way where we could compare. About 5 years ago, I started working, well, longer than that now, actually. I started working with graph databases In particular, started developing knowledge graphs. And one of the things I was asked to do is how can I use that to find the appropriate skills or lack of skills in our organization? So I took that to create a database that allows me to take an occupation, for example, and there are various open source or publicly available databases on occupation, ONET being one of them. It's the Department of Labor's Occupation Network database. Within that database, they have a list of about 2,000 occupations with various elements that make up that occupation. Some of those elements are knowledge, skills, abilities, tasks, technologies. I took that information, turned it into a knowledge graph. So then we ended up we looked at that and created a model that will identify those skills within the occupation and associate them in a graph. But then I took that same thing and used a similarity model to see if I could find those same elements within an individual's information, their resume, their publications, and then say, okay, based on what I know about the individual, they have these particular skills. How do they align to the occupations that we have? So that was the kind of the start of it, but it can expand from there. Because from there, we can say now, if I have all of that information about an employee, and I have the information about an occupation, I can then say, I need an employee that has these types of skills. I can go through the database and find individuals that match what I'm looking for. But let's say they only match 75% of what I'm looking for. Well, turns out that if you think about it, training or any kind of training also has those same elements: knowledge, skills, abilities, tactics, and technology. So now I can tie training to those particular elements. So if I know I need to upskill somebody in a particular skill, these are the courses you need to take in order to get that right information. So I've solved several problems in that: identifying skills in an individual, finding the right people, and then if I can only get to a certain degree for that individual, I can then upskill them by knowing the training, and that helps me to identify the individuals I can upskill to do that. But it opens up the door for so many more things we can look at.
That's very interesting. And to what extent it works internally, and to what extent it works externally as well. So do you also work with that with candidates? For instance, you have somebody that has, let's say, 75% matching the skills and competencies. Do you also get back with feedback? Get back to them with feedback that they would probably need to take this and this and this course, or this is purely internal process?
Right now, it's purely internal, looking at our workforce internally to see what do we have the right individuals within our organization, or do we have any gaps in our skills that we're looking for? So most of this is really around what projects do we have that need work, that we have work due on, what individuals that can meet those skills necessary for that project or that work to be done. And if we can't meet them completely, what can we do to upskill them, or do we need to hire out? It's just something we don't have that we need to go out and hire out. So we can do a lot of different kind of gap analysis around skills, around training, or do career analysis, do a lot of different things, mostly internally right now. We're working towards trying to compare individuals that are trying to apply, but there's some legalities we have to look at and be careful with when we do something like that. So those are the things we're trying to be very careful with to make sure we do it appropriately and not just assume AI is going to allow us to find these people without the human element, because that's always going to be necessary.
It's very tricky part of it, like the whole AI, because it's another tool that can help us accelerate different processes, but as we know, that it also requires a skill to manage that. Is Correct. That something that garbage in, garbage out? How do you actually use AI or like data science in general to build a knowledge base? Because I can understand that you also have a lot of different resources that can be shared across different departments and help other people to upskill.
Yeah, so we're really looking at and researching a lot of ways we can utilize, in this particular generative AI now. I think that's been kind of a boom in the last couple of years, to see how we can utilize that across our organization to improve not only the productivity of our current employees, but can we help it to identify some skills or necessary things within individuals that may be coming in. So originally, when we started this whole project, it was all done using things such as Doc2Vec, a similarity model, or using other types of skill models that have been created to just find commonalities within sentences through some similarity models. Now we're trying to apply the same thing. If we can identify NASA specific competencies, can we train a model, a large language model against NASA competencies that we're looking for, identifying those, using that to help say this person, based on what we know about them, has this competency within them, even though they may not have specifically said, I know this or I know that. So the model maybe hopefully based on what the individual had written about or what they had worked on, can say we believe that this person may have the right skill set that were necessary. Then a human has to step in and say, okay, let's really look at this, let's evaluate that, let's see what we're doing. So we're working on various chatbots, we're working on various analytical capabilities around our data sets, asking questions around our data through a large language model to find answers. So to speed up the process of what we're trying to do. As you know, everybody's trying to do things leaner. And these types of technologies allows us to do things more accurately, faster, and really drive some data-driven insights.
And then what would be the most interesting or surprising discoveries through your work at NASA? Any particular?
Some of the most surprising things I think, again, I'm working in the human capital side. I'm working more in the mission support side. So my organization, it's there to support the missions. I think some of the things we've discovered, it's just a way that's surprising to me anyway, maybe not be surprising to other folks, but just to really help us identify the right people, to be able to take information quickly and utilizing that within a large language model or some other type of AI capability to identify these folks and really set up a career path or planning for an individual based on what they're doing right now, what they want to do. Can I compare it to other individuals that they want to model after? What is that career path they may want to take in order to meet those goals? So I think it's surprising to me is the capability that we're seeing now in some of these large language models that allows us to really help counsel and guide our workforce into a better path, a better role for them, and hopefully avoid some pitfalls.
And to what extent those models can be extrapolated to different industries, different companies, because you definitely deal with a lot of data and you have a very specific data. Like a lot of people are publishing papers that are available online. It's not that specific to every single industry. So how do you think it's possible to have similar models for upskilling and for matching different skills and competencies with particular roles within an organization in different industries, in different companies?
That's an excellent question. I think the process for what we're doing is easily replicated across industry and across other organizations. Even some of the competencies that we're looking at, while they may be specific to NASA, not necessarily that same competency can be used in maybe other organizations. Especially when we're talking about things such as analytics, engineering, data, web development, those types of things are across many organizations. It's the process of making sure that a company or an industry has defined the competencies the way they want to see them and they want to look at them. That information could be put back into a model to help identify specific skill set for that organization. So again, if we're talking about maybe the medical field, we could easily grab information from medical journals or information from medical competencies, capability indexes, or various different things to where we could add that back into a model and say, let's focus on just this type of industry. So the process is built to be easily moved. You just have to apply the right information for that industry in order to get the answers that you're looking for.
Very interesting. I want to spend a couple of minutes to talk about the technologies that you're using, because you're working mostly with open source. So if you could say, what is your technology stack? What are you working with?
At the base of it, like any other data science organization, we're using either Python or R right now. It's our private SQL are probably our biggest three languages that we use in order to pull information out of databases, transform it, do various analysis. So that's going to be the base of my coding capabilities that we have. But on top of that, we've been moving more towards a cloud-based in technology stack. So within that technology stack, of course, we've got our orchestration where we're using various different tools, Databricks, Airflow for some movement, Databricks for some storage and transformation. But when we start doing pure analysis within our environment, right now we're settling on the Closet ecosystem with their Connect server for visualization, their Workbench server for analysis. And the beauty of it is that my team is made up about 50-50 Python and R developers. Some of them really love R, some of them really love Python. Within the Workbench server, we can spin up either VS Code for Python or in our studio for R, but still be able to share and be on the same system in code. And with some of the newest iterations of the latest Positron IDE, we can actually do both Python and R in the same IDE, which is my team is really excited about the capabilities that's providing for that. And then from our business intelligence side, we've got things like Power BI and Tableau, like other folks probably use, in order to showcase some of the descriptive analytics. We're still working on more developing other analytical products for our models, for our AI models, ML models that we need to share out, and APIs that we may use to allow our folks to access those models for their needs.
What are you working with right now? What are the your major 2-3 projects, or the major 2-3 goals that you have for the upcoming months or maybe the whole year?
Well, right now, I think our biggest product is how do we actually integrate generative AI into our pipeline, into our processing. So I've got a project we call the Human Capital Intelligent Query System. We named that to help us utilize large language models to extract information from our human capital data. And there's a couple of ways we're looking at that. One is just your simple RAG type based capability, various forms of RAG within that architecture, just to answer questions against human capital policies and information. How do I change my time card? How do I update my W-2? How do I classify a particular job analysis? Those type of things that we may have policies and procedures for, that our human capital workforce needs in order to answer questions to our supervisors and to other individuals. The next part of that is we get a lot of questions about our workforce internally, of course, about just simple questions. How many people do we have today? Can you tell me, what's the number of people in a certain position? How many people work in a certain center? Those type of questions should be easy enough to answer, again, with the generative AI model against that database. So we're looking at a way of another part of that project is to ask questions against our database to answer those type of questions, so that I don't have to, or my team doesn't have to do a quick query to do that. We can just have an interface where our staff or the employee workforce can go in there, ask this question, and get that data back. And then another part of that, of course, is how do we use knowledge graphs within our capability of utilizing the large language models. So those are the top 3 things we're working on right now to try to enable our workforce to do more with the data we have at a little faster pace, and hopefully for them to be able to find the answers a lot quicker and be able to, again, to help support the missions of what they're trying to do.
Okay, I just focus. Probably there are some people who would be interested in that as well. What advice would you give, either based on your own experience or data that you have seen over the course of your whole career? What advice would you give to a person who wants to work for NASA?
Oh, I think part of it is a passion. It's a passion for a particular area or a field. So NASA, everybody, look at NASA and you think, okay, they've been to the moon and they're trying to go back to Mars. They're trying to go to Mars. And you think it's all about space exploration. What a good portion of it is, don't get me wrong, but we do a lot of different things. You see NASA's hand in many types of technology, transformation type capabilities. You've seen our hands in climate change, climate control, in the development of satellites, in the development of medical technology. So there's a lot of different things that we have our hands in capability based on the research we're doing. So it's really trying to find a passion that you're interested in and seeing how that fits into NASA. And showing that passion, I think, is part of what we look for. We're looking for individuals that, at least this is my perception, we look for individuals that are really interested in what they're working on and wanting to make a difference. It's not about the money. We don't get paid that as good as well as we can in industry, but it's about what we can do to make a difference to humanity and how we can drive the mission of NASA forward.
I think it's a really nice summary of the whole conversation to certify the positive note. But I also want to ask you the final question that we will ask to all our guests in the podcast. What's the problem in your field that you are surprised that hasn't been solved yet?
Problem in my field that hasn't been solved yet. That's and I have a couple of that I'm thinking about. I'm trying to give you the right one, or at least one, because I think it applies to many fields. It's really one of the hardest things that I'm surprised we have is it's an easy accessibility to the data. I mean, I know there's a lot of organizations out there there are a lot of vendors that out there that have access to have these databases and data lakes, data meshes, data fabric, whatever you want to call these types of things. But I just find it surprisingly, we really haven't figured out the right way to move data from one place to another in the appropriate format. And how do we make it accessible, interoperable across? And it could be more that every vendor has their own way of doing things. That's part of the problem. But that really sticks in my craw because it all starts with the data. Everything that we do, the data has to be there. It has to be accessible. It has to be clean. It has to be ready. If we could spend less time worrying about cleaning it and more analyzing it, I think we can move the needle a lot further and faster. And if I go beyond that, if I look at the industry itself, human capital or people analytics, I think part of it is the hardest problem I think we're going to need to try to face is how do we incorporate some of these technologies without risking an impact on the people that are trying to apply for these positions? How do we make sure that the models we're generating, the AI that's being used, is unbiased in trying to find the people for a position? That's still something that's going to be difficult to do, and that's why people will always need to be in this part of the process. But if we could help the individual do things faster, I think we can get the workforce moving faster. So I think those are a couple of things anyway that I think I wish we could figure out the right way of doing it.
It's probably a lot more problems. But I think we can finish now. Thank you so much for joining. It was very interesting to listen to the insights from your field. And to all listeners, if you did like the episode, please click the subscribe button, and we're gonna see each other in the next episode. Thank you so much, David.
Thank you very much, Nat. It's a pleasure being here.
Thank you for listening. This was Where Technology Meets Science by Upskilling. If you know someone who might enjoy this episode, share it with them and subscribe to never miss a new episode. At Upskilling, we empower pharmaceutical and life science companies to leverage open source technology for faster data-driven decision-making in regulated environments. Until the next time.